2010 relative velocity question 2. We're giving position vectors and we're given velocities of A and B. Find the velocity of B relative to A. B relative to A. The velocity of B minus the velocity of A. So we have 5I minus 7j minus 4I minus 3j, which is 5I minus 4I, which is I, and we have minus 7I plus, or sorry, minus 7j plus 3j, which is minus 4j. The velocity of B relative to A. Normally they ask the magnitude in this question. I'd always get it anyway. The magnitude, square root of 1 squared plus 4 squared, which is equal to root 17. Is it meters per second? Some sort of units per second or per hour or whatever. It doesn't really give us that, so it's just units. And then we have the angle theta is equal to the inverse tan of 4 over 1, and the inverse tan of 4 over 1 is equal to 75.963 degrees, so 75.96 degrees, and that's in a positive negative direction from up here. So my positive negative direction is south of east, south of east. So that's what's happening here. Now we're asked to show that they collide. So to show they collide, if we take they have to get to the same place at the same time. So if we take A starts at 6I minus 14j, and after 1 unit of time it moves up 4I minus 3j, it's going to get to 10I minus 17j. Now we could probably just keep going, up 4 down 3, 14I minus 20j, up 4 down 3. So then we have 18I minus 23j. Let's just start B to see are we on the right track here. B starts at 3I minus 2j and moves up 5I minus 7j every unit of time. So after 1 unit it's going to be at, this is T is 1, 2, 3 and 4, 5 if we need. 8I minus 9j, up 5 down 7. 13I minus 16j, up 5, this looks good. 18I down 7. Bingo, they collide at 3 hours. They're in the same position at the same time. So what's going on here? We've taken R of A, the relative position of A, and we've added on the velocity times t. And we'd have to show that the relative position of B is equal to the relative position of B plus the velocity of B times t. If we find the time t here and we can show that the I and j are the same, we'll get exactly what we have up here. So if trial and error doesn't work really quickly, it could be a half, could be a quarter, a third, it might be a little bit awkward. This is the maths behind it. So 6I minus 14j plus 4I minus 3j times t is equal to the relative position of B, which is 3I minus 2j, all from up here. And we'd have to add on the velocity 5I minus 7j times t. And is there a t here? Can we simplify it a bit like complex numbers, get our real and imaginary parts? So we're going to simplify the I part and the j part down on each side here. So we're going to get 6I plus 4it. 6 plus 4i, 6 plus 4t times I. Don't leave out your t. 6 plus 4it so plus 4ti. Then I'm going to have, I'll put a plus in the middle, but I'm going to have minus 14, and I'm going to have minus 3jt, minus 3jt will go like that. That's equal to 3i plus 5it, 3 plus 5it, and we're going to have plus, and we're going to have minus 2. We're going to have minus 7jt, minus 7jt. So let's equate the I parts. So is there a solution for t with 6? So these have to be the same for them to be in the same position. So 6 plus 4t would have to be equal to 3 plus 5t. So we'd end up, if I bring the t to the right, 5t minus 4t, 6 minus 3 is 3, which is what we got up above, isn't it? T was equal to 3. So you don't need to do this bit, it's just another way to do it. And then if t is equal to 3, what's my j components? These must be equal to minus 14 minus 9 is minus 23, and this one minus 2 minus 21 is also minus 23. So the position is going to be, as we saw up above, 18 and minus 23j.